Hi everyone, my name is Wojciech Mazur. I'm working in Virtuous Labs, and I'm doing a bit of work on the compiler, a bit of on the tooling side, and maybe you don't know, but we specialize a bit in the Bazel. So I'd like to today introduce you a bit to this build tool and how can you actually start building your programs with Bazel and how to make it a bit easier with dedicated tools. And this tool is actually called Gazelle. So also something about me, work in the compiler, doing the releases of Scala 3, so some blog posts, and sometimes some not very nice releases. We had some bad times as well. But yeah, also like making sure that there's no new regressions in the compiler. In free time, I'm also doing some work on the Scala native. And beside that, for the more commercial projects, I'm doing some migrations, for example, from Scala 2 to Scala 3, some work on migrations to Bazel, for example, from SBT, or more a bit low-level build tools, maybe CMake or something like that. And also with our friends from Ankflow, I was recently developing the Gazelle for the C and C++. Today, as I mentioned to you, we would first start with the introduction to the Bazel, quick overview. Later, quick overview how Gazelle works, what it is, how it helps you, why we need it. Later, let's hope that the live demo guts would be pleasant to me, and I would be able to show you something how to migrate actually one project from SBT to Bazel. It would be actually leeches. And last but not least, I would try to show you how can you actually create your own Gazelle extensions for different kind of Bazel rules. So let's begin. So if you don't know Bazel yet, it's a build tool created by Google, originally named Blaze, but then when they have open sourced that, they have renamed it a bit. And it wants to be like the best build tool for large monorepos when you have thousands of files, not lines of codes, but files, hundreds of modules, multiple languages. You mix Java, Python, C, or whatever you want. And it needs to scale. It needs to be buildable. You need to be able to actually be efficient still, even though there is so much of different dependencies and different things to control. So first thing that actually Bazel promises is being incremental. So you don't only have the incremental build, but you also have the incremental tests. So that's actually the feature that is going to be ported to the SBT. Luckily, I have just MyTalk instead of Eugene, so you know. But you would learn about it anyway in the future. The incrementality is only possible because a very build of the Bazel is deterministic. It has deterministic inputs and deterministic outputs. Everything that you build is actually sandboxed. You, for example, don't have access to any ordinary file system, so no random access to the files. You need to explicitly enable it and say, for example, which files can be used. And, for example, you can have some limited access to the internet as well during the build. And this is to ensure that your build is actually reproducible. So we can, for example, use the same build configuration. And, for example, if you build C and C++, you can just run it on Linux machine, macOS machine, Windows machine. It still should work, or it should be at least configurable to the point where it can be cross-compiled from different platforms. Besides that, some other features like the remote caching, the stuff that you maybe have seen on the Gradle booth with the Velocity is, for example, using the build event protocol to show some nice UIs that are possible thanks to this stuff. And one other thing that, for example, our friends from Ankflow are doing are, for example, the remote build execution. So you don't need to build everything locally. You can have some very trash laptop to develop locally and still build, for example, in the data center on some compute farm and build it on tens or, for example, on tens of machines that are specialized just for that. There are many other nice features that it has, but we have limited time. So let's say that you actually want to create some hello world in Bazel, the simplest possible application. What do you need? First thing, you need a set of rules. Rules are the things that actually are written in a star lark. That's a subset of Python that defines functions that you can use to interact with Bazel. So they actually implement actual interaction with different compilers, different tool chains, some setups, code generation, whatever you need. And there exists one official one in the basic contrib rules Scala. And if you want to access that, you would now, for example, create a module.bazel file. That's like the core file that defines your dependencies of your build. It's a bit like plugins.sbt, which allows you to extend your build tool with additional capabilities, with additional plugins. So we can use something like that. There exists a special registry where all of possible extensions, let's so call it, are listed under the registry bazel.build, and they are very easy to use. And it actually handles most of the eviction and using different libraries. Because previously, when you have used the legacy workspaces, it was a real mess. Now it's much more easier. Last but not least, you need to create at least one build file. Build files are like the atomic, let's say, form of defining a build tool. You typically have at least one. Typically, that's a one per directory, because Bazel encourages you to have multiple build files, so it makes your build fine-grained. You don't have one large file that defines everything, but you rather want to scrap it around your code base. In our case, we'd use can now, for example, load one of the rules called Scala binary from rules Scala, put some sources in it, define the main class to be run, and it runs. But wait a minute, 80 seconds to build a hello world? Yeah, that's true, but that's only because we've done building that for the first time. On the second evocation, actually, it's much faster. Why? Because on the first evocation, you actually build your build tool of the dependencies. Of that is later cached, and typically that would be dependencies of your rules. So, for example, the whole stuff from the rules at Scala. And let's say now that you want to, in your hello world, read a message from a text file. So normally you would just do it as always, but now no file found exception. Why is that? I told you before, we have sandboxing. You cannot just access any data. You need to explicitly point that it is available. So if, for example, you can create a file group to list some files that would be accessible, and then pass it to as the data attribute, and then it's actually buildable. Of course, I normally would like to have some libraries, some tests, and for this we have dedicated rules that are propagating this stuff. So you can create Scala library, Scala test. Rules.scala by default enable Scala test, spets2, and I think JUnit. And this you can use without defining any explicitly external dependencies. You just need to add this one little thing in a module.bazel to just enable the stuff, and you're ready to build. On the first start, you can see it works. We have added actually the flag test output all, because by default, the outputs are actually not visible, because remember, typically we might have tens, hundreds of unit tests, and we don't want to spam your terminal with the results. If you would run it again, we'd see that actually our tests have been cached. We don't execute them because inputs have not changed at all. Okay, so let's make something a bit more complicated right now. As you know, no project lives in a void. We need external dependencies. So let's say that I want to use some simple HTTP client, send request to some website which returns my IP address. And it just returns that in a JSON format, so I need to somehow extract it. So I'm going to use a toolkit, which provides us with STTP and UPICO and additional dependency which adds support for the name tuples. But how do you actually add the external dependencies? For that, you of course have dedicated rules. These ones lives in the rules JVM external. This is one shared between all JVM languages and provides us with Maven extension. And this one allows us to define external dependencies, which would be downloaded using Cursor, cached somewhere. And it also provides us with so-called log file. And this file ensures us that every single file, jar that we have, has the correct checksum. So we can ensure that it's not malformed, that maybe it's not suspicious at all, that it is expected. So we can control if any changes on the class path might happen a bit better. So now we can refer actually to these added dependencies using labels. Actually, it might be a bit cryptic in here because this name here, it doesn't really look that nice like the definition of the artifact above. However, the general rule is that you simply replace any character that is not non-alphanumeric with underscore because that's a name of a label, because it needs to be consistent and normalized. There exists a function that actually allows you to convert from the normal name to this label. However, it is a bit discouraged because tooling might not always work great with it. Anyway, we have added dependencies, right? It should build. No, it doesn't build. Why? STDP clearly is a part of toolkit, right? However, it says that STDP is not found. Why is that? That's how class path is handled in Bazel by default. By default, in Bazel, a very single dependency needs to be explicitly marked. So you cannot have like transitive top-level library dependency and add everything in one go. Instead, you have to explicitly list a very single thing that you add on the class path. There are some exceptions from that, but in general, that's the default behavior of rule Scala and default behavior for the Java rules. However, rules Scala have a special mode that allows you to enable transitive dependency, and then you just, for example, for the sake of migration, it makes everything much easier. It's the easiest way to just compile project, but it's less strict, and some undeclared usages might creep in. There is also a third mode, +1, so you add the direct dependencies and their direct dependencies. So one use case, a good use case for that would be, for example, library that is using macros, at least in Scala 2, because this needs to be separate. So this might be a kind of good middle ground. So let's adapt our code. We know our dependencies. We can take a look in our Maven.json for dependencies of the toolkit. We add a very single one to the dependencies, and it finally builds. A lot of work, right? So let's try to set up this transitive mode. For that, we first need to set up our custom Scala toolchain. Toolchain is a configuration telling Bazel how to interact with your compiler. So in our case, we can set up the dependency mode to transitive. We would also set up some default classy options that we might want, for example, to warn about unused variables. And we would also set the strict dependencies mode that might be useful in just a minute. We can define it. We can define then the generic toolchain and link it against, and then we need to register that. And now we can actually, our original Scala binary target successfully compiles, and thanks to our strict dependencies mode, actually we can see warnings for a very single usage of external library that is not explicitly added. So with this information, it's quite easy to get from transitive to +1 mode, if you really want, and limit amount of dependencies. But let's be honest, that's a lot of work, right? So you need to add sources manually, you need to manage dependencies, and ensure that everything is added. And that's why the Gazelle was created. Originally, it was created for the Go. It's a build file generator. So all the build files that we have seen, we have seen one build file, are generated automatically using some well-known, one strict naming convention. Typically, In terms of Go, it's a single, for the libraries, it takes all non-library sources and puts them together. There's something similar for the tests, so they match on the suffixes of the files, and it's able to resolve dependencies. And even though there exist 3 default rules, let's say extensions for the Gazelle, Go, protobuf, and a set of rules to set visibilities to targets. Yeah, that's one thing I haven't mentioned previously. You can limit the scope where some targets are visible. So, for example, service I cannot depend on stuff from service B. It lives in different submodules, let's say. However, there is also a lot of other extensions. So C and C++, which I have worked on, Rust, Java, Bazel for the standard itself, JavaScript, and many more. And actually, it's quite easy to create your own. I hope I will be able to show it today. So let's try to add Gazelle to our project. How do you actually use that? So in the module.bazel, again, we add dependencies, right? And in, for example, top-level build, we would add the Gazelle binary and would define the extensions that we want to run. So default 2 ones are Go and protobuf. Actually, they are in wrong order, but never mind. And you can define your custom ones, for example, C++ or the Scala Gazelle that we would try to show later, or something that maybe you have defined in your own repository. And then you can just run it like any ordinary binary, and it would generate these binaries. You can also pass as the arguments the directories to limit the scope where you want changes to be applied. So maybe it can save some time in some cases, or set up some configuration. However, if there will be like more of these arguments, it's recommended to actually create the Gazelle target. That actually is able to do it all of that. You can also then provide additional data, for example, resources like with Maven JSON that we have used, that might be sometimes required by the Gazelle extension to run, to provide it with some additional context. And by default, actually, the best way to configure Gazelle is by using directives. In comments in the build files can have special definition when they are starting with Gazelle. They would be parsed by Gazelle itself and propagated to extensions so they can handle them. And here we can, for example, exclude some directories. For example, if they have some special handling that needs to be done manually, or maybe you can, for example, in some cases, fix some resolutions strategies for some dependencies that might not be working that good, or in cases when there are some conflicts. For example, one typical thing that you might approach is, for example, having 2 different jars that have the same packages defined, and you import something via wildcard. So in that case, you don't really know from which one it should be actually imported, right? This configuration by the directives is actually derived or inherited by subdirectories, so you can tweak it if needed. And actually exists 2 Scala Gazelle extensions. There is one that was actually published like a month ago by the Foursquare. From what I know, they are using that on their 2 million lines of code base, and it's working quite nice. Actually, currently it's limited mostly to the Scala 2.12 and 2.13. However, there isn't that much work to make it work with the Scala 3. It's mostly about modifying their logic and adapting the 3-seater with some special handling, for example, for the extension methods, for the exports, all the new stuff that was added in the Scala 3. I have that in my fork, and I'm going to actually contribute it to the original repository after the conference. There is also the second one made by the StackB. This one actually exists for years already. It's using a bit different approach. However, it is a bit crooked. It actually it is not able to create Scala libraries, no new rules. However, it has a bit more complex and a bit more advanced logic for resolving dependencies. So, for example, it is able to, for example, index your jars that you have in the class path to get more information, to not patch only by the packages, but also by the actual symbols that are defined. You can use semantic DB for some reason, and many other inputs. And you also have some configurable conflict resolvers. Okay, I promised some live demo, so let's switch our window. And here I have my Lichess Lila library. Actually have prepared some small script to show how much files there is. It's actually mostly the HTTP server with using framework. Sorry. So we have the main app in here. Oh yeah, sure, yeah. Actually better. Yeah, okay. We have some configurations. We have some resources, and we have modules. Actually, it has 87 small libraries defined in here. It is following the diamond architecture, so there is one core library, and there is like a small number of other submodules that depend on it. So actually, we are able to build it in parallel. So in general, there's like 1,300 sources, 200,000 lines of code in general. So it's quite big, right? So maybe where do we start? It is already, currently, it's using the SBT. And we would need to somehow figure out what are the dependencies. I have already prepared some configuration for the Gazelle in the module.bazel, so I have the initial steps configured. I'm also using my fork of the Scala Gazelle. And what do we actually need is to figure out dependencies. I have written a small script that injects SBT build with custom task, which would actually list me all the library dependencies using the in the IV format, so it's easy to add because that's what Maven extension is using. And it also adds the cross-version suffixes because by default SBT does not show that to add. So it's generated. Oh yeah, and it also lists the repositories that it is using because I know that Lichess is using its own repository somewhere. So it has generated me kindly all the dependencies used. So let me just copy that in here. Yeah. And we have next steps. Now I should actually download these artifacts and pin them so I can ensure that they don't change. But I have already done that. So let me just run repin to ensure that the artifacts are exactly the same. And I can see some deadlock. Oh no. Yeah. There might be some connectivity issues. Let's hope not. Let's give it a few seconds. Okay. Oh yeah, that's why. I haven't configured the log file. It was searching for something that does not exist. For something there might be some bug. Anyway, I have updated that. Maven file is not modified. I have the dependencies. So, and I have also prepared my top-level build file, and here I have prepared the Gazelle binary. I have added the Maven install JSON file. It would provide the Scala Gazelle with the information about the class path that is available somewhere. And I have set up the default toolchain to use a transitive mode and set up all the settings that actually SBT was using at that time. Okay, so now let's run the Gazelle. And I would like to run it on these two directories that contains the sources I'm interested. And we might need to wait a second or two. Right now, it is actually the sources are being parsed, imports are being exported, we are checking for the symbols that are used somewhere, we collect all the class definitions, and this would be later used for internal dependencies resolution, for the internal modules. And it's building 3-seater, as I said, building the dependencies of the Bazel itself. And yeah, it has run. I forgot about one thing, actually. The Gazelle, rules Scala Gazelle, actually requires a hint from us. It requires at least one build file to exist, so we can figure out the layout of our project. It is because in Scala we might have a different layouts, and sometimes we, for example, might have subdirectories that depend on parent directory. In ideal world, you would have made a very single directory a custom target, a custom package, so that we would have the least possible amount of dependencies existing. But actually, this code base actually needs to be adapted just a bit. Okay, so I have now populated the empty modules, empty build files. There is nothing. Let's run the Gazelle again. And yeah, this one we don't need to build it from the scratch. And it has actually generated us with some Scala library. It has added all the sources that it has found. It set some default visibility. It has set up both internal dependencies for the other modules that exist in this repository. It has figured out, based on the imports, the external dependencies and added them. And we also have some tests in here. So now we can try to build it. So let's start with modules, and maybe let's start with a single target. And like I said, now again, building dependencies. It happens, yeah, that's unfortunate that we actually need to wait sometimes, but as I said, it happens typically only once. In that case, we are building protobuf, because to build, that's the dependency of rules Scala, and that's the first time we are actually going to use them. As we are waiting, let's get back to we will be right back. Let's get back into the Gazelle. So, what do you actually would need to create a Gazelle extension by your own? Basically, Gazelle is written in Go, and you can extend it by implementing one of the Go interfaces called the language. And it has a bunch of functions to be implemented. However, the four actually that are really important are the generate rules, configure, imports, and resolve, and also the import specs structure that actually is used to store symbols that are to be found or are indexable from our build. So in the first phase, Gazelle, what it would do, it would actually traverse all the directories that we have in our code base. It actually would do it twice. On the first phase, it would go through all directories. On entering to each directory, it would configure this potential submodule. So it would, for example, read the directives from the build file if it exists. And then it would continue working in the subdirectories. And starting from the leaf nodes, it actually would generate actual rules. And later, for every generated rule, it would index the symbols that are exported from it. So the symbols that are now exposed. In the second phase, it actually, based on this build index, it would try to resolve dependencies. So it would need to walk a bit for the second time. So when it comes to generating to the rules generation, we actually have struct that is passing us all the context for the generator. It's the configuration that we have derived. It's the relative path, which would be later used to encode the Bazel package. And we'd have all the information required about subdirectories, regular files in here. And also, if it is important, we have at the very bottom the outputs from other roles. Because, for example, when creating Scala proto library, so implementation of protobuf in Scala, it would typically depend on output from proto library, which is just like generic rule for creating rules for protobuf. And as a result, we need to have need to produce a generated result, and it contains new rules that that we are creating. Each of them needs to have a matching entry in the import, which contains the informations about important libraries. So it will basically contain the imports of fully qualified symbols that we, for example, reference. And let's remember that it's not only generator, but it also needs to sometimes remove rules that are stale. So I can populate it with rules that we have found out that are no longer used. For example, the sources that we're referring to are no longer existing, for example. There are some other stuff, but we don't have time for this. Let's get back. Yeah. So the core project has been built. It took us a minute, but it's there. So now let's try to build all these modules that we had previously in parallel in here. We get some warnings from the Maven, but that's not very important for us. Is it downloading? No, I hope not. Anyway, right now we have 4 parallel builds for our targets. As this would finish, the new builds would be triggered. We actually have a counter of all the targets that are actually have been built and all the targets that needs to be built. This counter might grow as we would discover something that also needs to build, some new additional dependency. So in general, it seems to simply work. Everything builds, and we can give it a minute to finish. In the meantime, as the project is building, let's get back to generating rules. So in our case, based on the inputs that are provided by Gazelle, with all the information about the files, we would, for example, create a new rule of some kind. For example, that would be a Scala library. It can be something different. If you, for example, create a Gazelle extension for Haskell, it might be something created some rules or that are specific to this library. And we would populate it with, for example, sources. Everything that we do is basically set the attributes on the generic rule. It accepts any kind, like the interface, but typically these are the inputs of the attributes are typically strings or list of strings. If it's something custom, you need to be sure to later handle that by yourself, and it should not really leak to that sort of word. These attributes would be later, directly translated to the attributes in the build file of your target. Later, when you actually would create a rule, it would need to be also imported. But the naming of the imports might be confusing because the imports function actually contains not dependencies for target, but rather exported symbols. So here we actually create an index. We populate the index of fully qualified classes, traits that are exposed by this single target that are public and can be used somewhere else. And to be honest, they will be used in the resolve function in the second phase, based on the imports that we have set in this struct. Let's get back to our build. It has built everything. It took 90 seconds, so maybe you can now test it out. Yeah, everything's being working on in the parallel, and we should see some results in a few seconds. And you should see by default a summary where everything builds and passes the tests. One thing that actually is left is to actually build the application itself. It should be binary, but currently the rule Scala is not, the Foursquare rule Scala is not capable of creating Scala binaries, but it's quite easy to do. We just need to search for modules that create main classes by other annotation, or using the old style, like the Scala 2, where we define main method explicitly. And this one also is populated. We can build it and run it in theory. Oh yeah, actually it is building already. Yeah, okay. Okay. So what might be the actual problems with the Gazelle? So one thing actually that is quite problematic in general if working with these tools is sometimes the lack of context. Let's say that, for example, you import some symbols from the wildcard. We know because, for example, IDE would tell us that it's actually coming from the dependency module. Yeah? So we might guess that the getBytes is some static function. But just by analyzing the sources in a language like Scala, we can't really know everything, because in fact, that's not a class, that's not a static method, it's just a method from the string, and we have just tried to reference something from the module, right? And this kind of ambiguities or lack of context might make tools like the Gazelle not able sometimes to resolve dependencies correctly. So the more inputs that you would actually provide to your sources, if you would, for example, use fully qualified imports, it's much easier. Otherwise, we can, of course, try to implement some heuristics and extracting stuff, assuming that something might be coming from some package or from something else, but sometimes it's really hard. For example, we might have an inline methods. So something that at top level is importing a static function and might actually be defined in some different module. In some other context, might simply be the inline import to import a method from the parameter. And it's hard to sometimes to handle cases like that. At least from the point of view of syntax and the outputs that might be provided by either Scala metaparser, tree-sitter, or from the Scala compiler itself, parser, it might look the same, but we need to have different heuristics how to actually resolve that, and, for example, filter out everything that might be imported from possibly local variables. And there's one other problem that is very painful, macros, especially Scala 2 macros, which might really hide some stuff that is not imported in a way. There might be no clear marks about where something is coming from, and might eject some dependencies that you might not really expect. In Scala, it's a bit easier because these symbols would already be imported to the library itself, and we also don't need additional modules. But it's one of the things to remember that might be problematic. Are there other problems, other limitations? Yeah, actually there are. Not only like in terms of syntax itself, but for example, when it comes to handling different dialects sometimes. You might, for example, need to have special handling either when you use source future in Scala 3, if you want to use Scala 2.11, there is some deprecated syntax. Not every single Bazel might know which one it should use, so parsing might not be as effective. Also, as I mentioned previously, the more context you have, it's easier to resolve. But if you, for example, have two targets, two jars that have the same packages, it's really easy to have a conflict, because just from the Maven install, we only get information about which packages are available. So to get the exact information, there is some indexes that need to be made. And let's remember that the Gazelle would not be run on some small project typically, but rather on some big repos. It might take tens of seconds, minutes, sometimes even if it's really big. And if the logic would be too complex, it might be counter-effective. I think we are actually out of the time. However, if you have some questions, I'll be waiting on the stand. You can ask me about Bazel, about Gazelle, about Scala, Scala Native, do you want? So anyway, thank you for today's talk, and thank you for coming.